All right, let's take a look at some situations that require either the loan formula or the payout annuity formula. You can afford a $600 per month payment on a car. The company is offering a 3% interest rate for 48 months or 4 years. How big of a car loan can you afford? Okay, so a couple of things that are different from previous examples is the fact that we're talking about a monthly and then also payment. There's only one formula that's used for the payment problems, and that's this formula. So one thing I like to consider is the fact that we have a negative exponent in this formula versus the savings annuity formula. This negative is what creates a situation or a model where the money is decreasing over time. What money is that? The money you borrow from the bank to buy this car decreases over time until you finally pay off the car, and then the money that's borrowed from the bank is zero. So it starts off with the price of the car and decreases each time you make a monthly payment until it goes to zero. This negative exponent is what creates that decrease model that works well for this situation. Okay, next up, the D value is, I'm going to just highlight the negative. That's nice. Okay, the D value, how much your monthly or yearly or annual, whatever they say, how much you are paying in the payment, it goes in the D. The fact that it says monthly, that's where we get the N value from. And then we also have 3%. That's going to go in R, but not exactly. We have to divide by 100. And finally, we have this 48. Now, very similarly, we also have this 4. The 48 actually represents NT, and the 4 represents T. If you're given the number of years, that's always the T value. If you're given how many payments, which is if it's monthly payments and it's 48 months, that's how many payments. NT stands for how many payments are made in the course of this loan. I will probably stick with the 4 for T so it looks a little more standard, but that's up to you. All right, so P sub 0 equals D, that's 600, parenthesis, 1 minus, parenthesis, 1 plus, R. Now for R, we have to take our 3%, divide by, oh, not the percent. The percent sign changes to divide by 100, 0.03, over N, and N was monthly, N equals 12, to the negative N, 12, times T, 4. So here, the N, T, separately N and T, 12 times 4 is 48. So 48 also could have been used for the entire NT. Divide by, parenthesis, R over N, 0.03 over 12. Now I'm missing one parenthesis right there. It's important to see your open close parenthesis sets are correct, because if you leave off this parenthesis, then that stuff jumps into the numerator where it doesn't belong. All right, this mode, I'm going to go, let's do the classic first. So this would be 600 parenthesis 1 minus parenthesis 1 plus 0.03 divided by 12, close parenthesis, exponent. Now here we have trouble, and that trouble is the exponent has more than one operation involved. Specifically, it has this times involved. So in order to keep all of that in the exponent, a parenthesis would be appropriate. Oh, wrong color, sorry. Make it look good. Okay, good. So parenthesis. Next up, this symbol, since it's not between two terms, it's not a subtraction. It's an opposite. It's a negative. So there's a difference between a negative symbol and a subtraction symbol, even though they look the same. And on our calculator, there is a subtraction, a verb, and a negative, an adjective to what we're dealing with. And we want the negative. If you use subtract, it'll give you an error. It's a common error that students run into. This should be the answer negative in parentheses, whereas this one before, the subtraction, way back here, that's a longer one. That was a subtraction. Okay, close that parenthesis. Now we also now need to close the numerator parenthesis, and then divide, and then the denominator. Once again, the denominator has an operation involved. So to keep that operation all intact, the denominator parenthesis needs to be used. It's already there, so that's good. Whereas the exponent parenthesis was not. You might consider changing that if your calculator needs that. Okay, back to the calculator. Divide by parenthesis, 0.03 divided by 12, close parenthesis, equals. A lot of work, $27,107, and we round to the nearest penny, and 0.216 changes to 0.22. So the initial value, that's the initial draw you can make from the bank, is $27,107.22. Okay. Now, a way to speed this up a little bit, this 0.03 divided by 12 shows up twice in this problem. So if we work it out first, and then use the answer button to call that up in our next expression, it's a little bit more efficient. Notice 600 parenthesis 1 minus parenthesis 1 plus answer parenthesis exponent parenthesis negative 12 times 4 close parenthesis numerator parenthesis divided by answer. A little more efficient. Obviously, same answer. Now, what if you have the math print? It's just a lot safer, I think. First off, this whole thing's a fraction. 600, parenthesis, 1 minus, parenthesis, 1 plus. By the way, you can do the answer, the 0.03 divided by 12 first if you'd like. Oh, go back, delete that down. 12, parenthesis, exponent. Here we don't need the parenthesis around the exponent, but we still need to use the negative sign, not the minus sign. And the denominator, since we have a fraction button, we don't need parentheses around it. We can tell that it's in the right spot. And one last, lots of stuff on this one just because I want you to use your calculator well. If we do that 12, the 0.03 divided by 12 first, now it looks even nicer. Might even fit all on one screen. Not quite, but close. More efficient still. All right, whichever way made the most sense, it's time for you to practice. So go ahead and pause the video as you work out this next question. What you should get is p sub 0 equals 243,932 and 24 cents. Great.